Hi everyone, welcome to the last lesson for today, unless you're looking at the optional lesson for radians. And this one is on, we've done Bedmas and trigonometric functions. Now we're going to look at how to graph sine x and cos x when they've been transformed. Graphing a sine x is square bracket k round bracket x minus d round bracket, square bracket, plus c, okay? And we can also think about cos x as well, but just think about a sine. Okay. So we're going to graph these transformed functions. So from your Desmos investigation, we already have a lot of the answers to these types of questions. So I'm going to go through this rather quickly, but we'll take a look at how the A, K, C, and D affect amplitude, phase shift, period, and horizontal axis in a more specific mathematical way. So we notice that A affected the amplitude of these functions. Here is sine x in black. If I have y is equal to 1/2 sine x, that would be the one in blue. And we notice that the zeros are the same, but that the function has been stretched, compressed towards the x-axis. So the amplitude is 1/2. The amplitude is given here. This is 1/2 of the original amplitude 1. And then if we had y is equal to sine 2x, well, then that gave us an increased amplitude here of 2. So that's an amplitude 2. So now increased. So this is affecting amplitude. Yeah. So what's the amplitude of g of x is equal to 15 sine x? It's not a trick question. It's just really easy. It's just 15. The amplitude is 15. So A is amplitude. Isn't that nice? It's easy to remember. Okay, that's the only one that's nice. It's easy to remember. Okay, K, on the other hand, that's a little trickier, right? Like, and this is in radians, but just remember this is a cosine graph, the blue one. Okay, and the blue one is the parent one. Oh wait, the black one is the parent cosine, and this is 180 degrees. This is oh geez, this is 360. Gosh, it's very early. This is 360. Okay, this is 180. And this is 90. Okay, here's your lesson on radians. Pi over 2 is 90. Pi is 180. 2 pi is 360. Okay, there. You don't need the optional lesson. No, you do. But anyway, and this is 270. Okay, here. So this is a cosine. It starts at its maximum, goes down, hits its minimum at 180, and its zeros are at 270 and 90. Okay, and when we change k, this one here has a k of 2. Okay, and we see 2 full periods within 360. This one has a k of 1/2. We're only seeing 1/2. Sorry, this has a k of 1/2, and we're only seeing 1/2 of a cycle within 360 degrees. Okay, so k is affecting period, but because the original period of our functions, the parent function of sine here has a period of 360. This is one full cycle. This is cosine, has a period of 360, has one full cycle there. So because 360 is the period of the parent function, these are the formulas you can use to calculate k. If you want to calculate k, but you know the period, you'd use this function, this formula. If you know the period and you want to know what k would give you that, you use this formula here. Okay, they're the same formula, just rearranged. So if I want to know, if I want to create a function that has a 60-second period, what value of k would I use? Well, I would write down k is equal to 360 over the desired period. Okay, so here my k would be equal to 6. Final answer. All right, so if I graph f of x is equal to sine of 6x, that's a k. Multiply my inputs. All right, and that will have a 60 unit period along the x-axis. Be useful for modeling like a Ferris wheel that goes around once every minute. Right, what about a 2-hour period? Well, there I could measure my x in hours, and I would again have k is equal to 360 over 2, and that would be equal to k is equal to 180. But what if I was measuring it in minutes? Well, then I would say k is equal to 360 over 120, because that's 2 hours in minutes. And so then k would be equal to 3. Okay, both are correct, but this is k is measured in hours, and this is in minutes. Different, but the same. Okay, now, what is the period of g of x is equal to sine 12x? Well, there I want to use this, because I'm given k, so let's calculate the period. Okay, so if I say the period is equal to 360 divided by this value k, divided by 12. Well, 360 divided by 12 is 30. So there the period of this function would be 30. Okay, how about g of x is equal to 1/2 sine x over 5? Okay, this is the trick question. This is an a value. It's affecting amplitude. It's not affecting period. So I'm only worried about this divide by 5. Okay, so if k is here, k is equal to 1 over 5, because multiplying by 1 over 5 is the same as dividing by 5. Okay, so it's the same thing. So I'm going to use this formula here. Period is equal to 360 over 1 over 5 is equal to 5 times 360, because I flip this and multiply. Okay, so that's equal to 3 times 360 is 1,500 plus 300 is 180, 1,800. Okay, there you go. So that's how you use these two formulas. So the period of this function will be 180. There's a trick, and I'll show you in Desmos. The k value shows you how many, let's get rid of that. Let's get rid of this, and this, and this. Okay, so I'll zoom out here. Oops, no. Don't zoom out, Mr. Jennings. Zoom in. There. So here is 360 degrees that we're looking at, and a little more, but there. That point there is 360 degrees. Right now we have a 9 there. Let's put in a 4. Okay. Let's put in a 2. Okay. So within 360 degrees, here we see 1, 2 full cycles of this function within 360 degrees. The value of k shows you how many full cycles you will get within 360. Okay, let's try 3. 1, 2, 3 full cycles. Okay, let's put in over 5 like we had. Okay. We see a fifth of a cycle within 360 degrees. That's only a fifth of a cycle. Okay, if we zoom out, we would see that we have to go through 5 full cycles to get to 1,800. See the period, 1,800? There's that number, 5 full cycles. 1, 2, 3, 4, 5 full cycles of the parent function before we get 1 full cycle of this transform function that's x over 5. Okay, so that's the trick with k. K shows you the total number of cycles you'll see in 360 degrees. But it's really these two formulas that you're going to be using to calculate values of k, or to calculate the period given to k. Now, what about d? This is the trickiest one. This is super tricky. I am at the level of conscious competence with this, not unconscious competence. I have to really think to get my d correct. D determines phase shift and how much things move left and right. Okay, so if we want to know the phase shift and the y-intercept of the following functions, really, if we want to know the y-intercept of the functions, there we're looking at f at 0, right? We want to know what is the function doing when x is 0. That will give us the y-intercept. So the phase shift here, x minus 30, this one has been shifted to the right 30 degrees. Okay, so if we imagine our parent function, which started in the middle and went up to a maximum at 90 and down, and then hit it, then completed a cycle at 360 and continued. Okay, then we have moved that 30 degrees that way. So the new y-intercept is the old negative 30. Okay, and that's been moved over here. Negative 30 degrees What's the sine of negative 30 degrees? Check your unit circle, everyone. Here's negative 30 degrees, and the value of sine is negative 1/2. So this has been phase shifted 30 degrees to the right, and its g at 0 is equal to 15 times 0 minus 30. So this is the negative 30. Remember, this is the sine negative 30. This is negative 1/2. This is 15 times negative 1/2. So this would be equal to 7.5. Negative 7.5. Okay, so that would be the y-intercept of this function is negative 7.5. How about this one? G of x equal to cosine 12x plus 10. Okay, so now this one has been shifted 10 units to the left. But before we did that, we compressed it. Compressed it by 12. So this one, if we multiply this out, this is 12x plus 120. So we're going to be seeing the value cosine of positive 120 there when x is 0. So that's going to be cosine of 120. Check your parent function. Here, 120 here, cosine. Cosine is given there, negative 1/2 again. Okay. So this will be negative 1/2. Now, let's take a look at it in Desmos. And these, you want to get some practice in Desmos looking at these functions. So we're looking at cosine of 12 times x plus 20. Okay. Notice there's a lot going on there. That's because we're way zoomed out. Let's zoom right in and take a look. Here we're going to move my face, turn off sine, just look at this one. We want to look at the y-intercept here. So remember I said it's going to be negative 1/2? Yeah, it's negative 1/2 there. Notice I have to really think about that because I'm only at the level of conscious competence. I really need to think to get these right. This is trickier. So what happened here? This was our old y-intercept. Let's change this to a slider d. Add the slider and make sure it can go up to 20 here. So, okay, there we go. So now, if we started at 0, there's cosine. It starts at 1. But it's been squeezed by factor 12. So we're seeing 12 full cycles before we get to 360. That means we see a full cycle here at 30 instead of 360. 360 divided by 12. That's our k. Okay. Now, if I move this d, notice what happens. This gets bigger. We're adding 20. See how that y-intercept is coming down, 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 down. And then, did I say it was negative 1/2? What are we looking at? I'm now super confused. But that happens. Oh yeah, x plus 10. Yeah. Okay, good. So 12x plus 10 here. So now we're looking at cosine 12x plus 10 because d is 10. And you see that this used to be there, but it got moved 10 units. So this is your 10 here. See, this is 50. If I zoom in, you'll see that that is negative 10. So that was moved 10 units to the... No, this way. I'm left, right. I'm so confused. That way. So this one was moved 10 units to the... That's left. Yeah, 10 units to the left. And it's now g at 0 is equal to negative 1/2. Okay. And why was that? Well, because it's like going negative 120. And we see that down there. Zoom out, you see it down there. There's the new y-intercept for this function. Yeah, okay, so how do you calculate these? Calculating these is something that we will cover more tomorrow when we look at modeling these things. Can't do everything today, and I'm conscious that some of these lessons have gone on fairly long. So we are going to move on. Today, do what I do, which is play in Desmos with sliders and move these things around and work things out algebraically and use your bedmas and understand that this is one of the trickier things we're doing this year. Yeah. C. C is very simple. Unconscious competence for me here. C is just the horizontal axis. So here's cosine x plus 5. Notice that it starts at its maximum and goes down. So that's its phase shift. And here's 5. There's the line y equals 5. Oh, it's affecting the horizontal axis, Mr. Jennings. Yes, very, very good. Okay. There's cosine minus 5. So here's the horizontal axis again. There at y equals minus 5. So horizontal axis. Here's a trick question if I ever saw one. Woof, that's a complicated function, isn't it? We've got that 12x plus 10 there. We've got 15 multiplied by that, but that's just... The horizontal axis is y is equal to 5. Okay, it's very simple with C. C is just your horizontal axis. It's exactly that equation. So now we've covered A, K, C, and D. So you want to now be able to look at something like this and say, I am going to create a function that's going to be that. Okay, so here, let's examine this function. And I want to create both a sine and a cosine equation for this graph. Let's start with cosine. That's going to be easier. Why? Well, I'm looking at it and I notice that its phase shift, it starts at its maximum and goes down, just like cosine. So phase shift is going to be, cosine is just 0. D is 0 when we're looking at cosine. Now, what's the period here? Well, it gets to 1 full cycle in 4. So the period is 4. So if I know the period is 4, then I can say K is equal to 360 divided by the period 4. So K is equal to 90. Okay, that's going to be useful when I'm creating a function. Now let's take a look at the amplitude. Well, to know the amplitude, I really need to know the equation of the horizontal axis. So let's see, 5, negative 1. The average of 5 and negative 1, 5 plus negative 1. This is my formula for finding the horizontal axis. Divide by 2. Just take the average of the maximum and the minimum. And that's going to be 5 plus negative 1 is 4. 4 divided by 2 is 2. So the axis here is along the line y equals 2. Notice that that cuts the function exactly in half. Y equals 2 is the axis. Okay, so now what's the amplitude? Well, amplitude is given by the height over the axis, and that's 3. 5 minus 2 is 3. Okay, if you want to know another way to do it, you can do the maximum minus the minimum and divide it by 2. And that's going to give you 3. So the amplitude is 3. Okay, so now I have everything I need to create a cosine function. Remember, D is 0 for cosine because there's no phase shift. It's starting at its maximum. So D is 0. So here, if I say f of x is equal to, the amplitude is A, 3 multiplied by cosine of, now what's the period? Well, it's K is 90. Cosine of 90 minus x minus d, which is 0. So I don't need these extra brackets. I could have just written 90x plus the axis. So plus c, so plus 2. Check it in decimals. Check your work. So here, I'm just going to get rid of that. I know that d is 0, so I have this. I know that cosine was 90, and I'm going to have here, what am I looking for? 3 was my amplitude, and then I added 2 to it. What am I looking at? Well, I'm way too wrong zoomed. Okay, so go up here, change your scale. We want to see the same amount of the x value as we had on there, so I'm going to just put in 10. And then here I'm just going to put in negative 10. And the y-axis we're seeing enough. All right, so let's compare this function and see if it's the same as the function we were looking at. So here, starts at 5, hits its minimum at 2, and the minimum should be negative 1. Here, 2, negative 1. We are correct, yay! Now let's see if we can do it with a sine. Okay, so I know that the amplitude is going to be the same. I know that the k is going to be the same. But I'm going to have some d that I have to do there. Okay, and then I know the horizontal axis is going to be the same. Add a slider for d. Okay, if d is 0, then we'll notice that that's not the same. Okay, I want this to move over there. I'm noticing that this is here at 1, and I would like to move it that way by 1. So I want to move this leftwise. So I am going to add here. There. Sine of x plus 1 will do it. Okay, that's using a slider and Desmos to figure it out. But then you're going to use this like playing around and just fudging it to make it work to learn how to calculate d. Okay, so let's go back here. I know that the answer is going to be plus 1 is what I'm going to be adding to my inputs. But let's work it out. F of x could also be written as a sine function. The amplitude will be the same. The phase shift is different. Sine of 90 multiplied by x plus some value. We know it's 1. We're going to work it out. Plus 2. Okay. If it weren't there, it would start here, go up, come down, and hit this one at the next 2. Okay. I know that I want it to start there at the maximum. The maximum was like the maximum of sine happens at 90. So I want this to be kicking out 90 when x is 0. So if I have in here plus some value d, okay, and I want that to equal 90, well, I would say 90 equals 90 times x plus d. But I know x is 0 because I want that to be my y-intercept. So 90 equals 90 times 0 plus d. Now I have one equation and one unknown. 90 times 0 is 0. 90 times d is 90d. 90 equals 90d. And we see here d is 1. Okay, so I can put that in. Move my face. Plus 1. There, that'll do it. So that's how you can calculate it if you know like what you want to be there. The other way is going to be a little more tricky, and I'll show you that more tomorrow. Again, phase shift is tricky. We're going to kick it down the road a little bit, but here are some practice questions for you. I want you to be able to tell me A, K, C, and D. What does amplitude correspond to? What does period correspond to? What does phase shift correspond to? What does the horizontal axis correspond to in terms of transformations? You can expect to see that on the exit ticket. And then we're going to take a look at a table of values and how you can generate a table of values for f of x is equal to 2 sine 3 x plus 20 minus 1. I'm going to quiz you on some of these values in the exit ticket for this function. And I want you to be able to show me exact values for the y-intercept and 2x intercept. So if I had 0 there for the x, what would be the exact value of f of x equal to 2 sine blah, 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 blah. Okay. And also, at what points does this equal 0? Okay. And then you should be able to graph that. Okay. The next thing that you should be able to do, again, I'll be quizzing you on this in the exit ticket, along with a few other questions, is can you create a sine and cosine function that will be exactly this, that has its minimums at -10, and the minimum is -11, and a minimum at 50, x is equal to 50, and y is equal to -11, hits its maximum over here. Okay, what is this value? What is that value? You could calculate those. I could quiz you on those, and you could give me exact values for those. Okay, so yeah, some challenging stuff to do on the exit ticket. But the main thing is find a sine function and a cosine function that will look like this. Okay, and we'll take that up tomorrow, but I'll be using the exit ticket today for remarks. All right, everyone. So best of luck with all the work today, and definitely hit me up for questions in the chat. Bye for now, everybody. You can also access me by email with your questions. And thank you again for showing up for your learning at a distance.